do.
I know you turned the recording off.
Yeah, I think it messed up. I'm blaming it on the grounds. How could I break that up to utilize a sum or difference formula?
So you do like 2 plus 1?
Yeah, I could do x plus 2x, right? Okay, so what am I going to get then? That's going to give me, so x is going to be u and 2x is v, let's say, right? So that's going to give me cosine x cosine 2x minus sine x sine 2x. And what is cosine 2x?
Cosine squared.
Cosine squared minus sine squared, right? Okay, so then you see that this part right here is just going to become cosine x times cosine squared x minus sine squared x minus sine x, and sine 2x is, yeah, 2 sine cosine, right? Okay?
Never got that.
Right? But that's how you can always do it. Right? So then, what do we end up with? If I distribute the cosine, I'm going to get cosine cubed x minus sine squared x cosine x minus 2 sine squared x cosine x, right? That's my cosine 3x. And I can combine these terms to make that a cosine cubed x minus 3 sine squared x cosine x, right? Everybody agree?
Yeah.
So cosine 3x becomes cosine cubed x minus 3. Those are like terms. I'm going to make it a cosine x sine squared x. I can factor that, right? What can I factor? Factor out a cosine x. And then I'm just left with cosine squared x minus 3 sine squared x, right? Okay? Everybody agree? Okay? So let's go back. Let's just take that.
Yeah, basically same thing.
So what's this? Here, I'll put that up here. So that was just what cosine 3x equaled, right? So now we got to plug all this stuff in. So what do we get here? So we're going to get a, if I plug that in here, we're going to get cosine x minus 1/6 times that stuff, right? Okay, we want to know when that equals 0. Do you know what can I do?
I can do cosine x again.
Okay, I can take a cosine x out again. Let's go ahead and take a 1/6 cosine x out, how about? Okay. So we're going to get 1/6 cosine x times 6, right? Minus the quantity, cosine squared x minus 3 sine squared x. Okay, everybody agree? Now what? So, simplify problem, right? So then I get 1/6 cosine x times what? Well, if I distribute the negative, I'm going to get 6 plus 3 sine squared x minus cosine squared x. So I got to find the solutions of this, right?
Yeah, that's when cosine x equals 0, so that's it.
So we're just gonna, right, so now we can apply the zero product property, right? But, so one of them's gonna be easy. One of them's gonna be where cosine x equals 0. It's gonna provide critical numbers. Let's focus on this one for a second, though. How are we gonna solve that? Or at least determine that it has no solutions?
Don't you wanna make it all the same?
Okay, so let's maybe make it all the same. Let's write it in terms of, let's say, cosine squared. Actually, it'd be easier to maybe turn this into sine squared, right? Cosine squared is just 1 minus sine squared, right? Okay, so then we could do this, right? We could say, just working in here, we're gonna get 6 plus 3 sine squared x minus the quantity 1 minus sine squared x, right? So if we distribute and add up like terms, minus 1 is gonna give us a 5 plus 3 sine, plus 4 sine squared x. Everybody agree? Okay, so let's set that one equal to 0 and solve, because we should be able to get this answer pretty quickly. If I set that equal to 0 and solve, wouldn't you get sine squared x equals negative 5/4? Right? Is that possible?
No,
No, for a couple of reasons. Why is that nonsense?
it's not the circles.
Okay, it's not on the unit circle, but there's something else. How can something squared equal a negative? Impossible, right? Something else. What's the maximum value of sine x? 1. Minimum value is negative 1. So even if that were positive, the maximum value of sine squared is 1, right? So what's that tell us?
That's just the cosine x that we need to worry
Yeah,
about.
no real solutions there, right? So the only one that's gonna give us real solutions is this guy, and that's gonna be when cosine x equals 0. Well, where on the unit circle does that happen? Where does cosine equal 0? There and there, right? Yeah, good. So in our domain, from 0 to 2 pi, it's gonna be pi halves and 3 halves pi. Okay, make sense? Okay. So okay. All right. So now what? So now we've got this thing down to, let's see, there's y prime, right? So we got to differentiate that and find y double prime. Because we are trying to, isn't this one where we're trying to find everything?
Yeah.
Oh, that's unfortunate, isn't it?
So would you go off into
That was
the?
your pick. That was your
first
pick
equation,
on
or
ours.
would you go off the equation that we thought of? Well, we're actually, it wants you to graph, that's all the directions say.
Want you to graph it.
Yes.
Yeah, and this is probably one, see, I'm extra mean to you guys, because in the book, a lot of times these will say graph it using graphing technology.
Yes,
That's just,
yeah.
come on, we gotta do this.
That's
Right. Bruh.
It's like, why do we pay $100 for these guys?
Exactly, you know, there's paperweights, right? So. So this was probably, I mean, do you see how now though, this is probably good review. Do you see how you'd have to attack this?
Yeah.
Right, I mean, you gotta use trig identities to break that up, because think about, and we've talked about this in the past, in order for us to solve a trig equation, we can't do anything with it until the angles or the arguments are all the same. So we've gotta be able to write this one in terms of trig functions of x, right, sines and cosines of x, before we have any hope of solving this, right? Okay, so now the second derivative, I think this will be a little bit easier though, honestly.
I doubt it.
So y double prime, so what's that gonna give us?
Negative sine x
And this is gonna give us
plus 1/2
plus 1/2
sine.
sine 3x, good. Okay, so sine 3x, we gotta deal with that whole issue. Let's go to the next page.
But cosine is easier, so. Or
Sine, I think sine should be easier.
Ow.
So sine of x plus 2x, what's that gonna give us? Well, you know, that's like u plus v, right? So that's gonna give us sine x times sine, no, cosine, sorry.
Wait, what was the basically, second derivative?
Say it again.
It was negative sine x plus 1/2 sine x plus 2x? It's just sine
You
x.
mean the trig identity you mean for this?
No, with the same-
Oh, never mind, I see what you did, yeah, I get you now.
Right. I just broke 3x into x plus
Yeah,
2x.
yeah.
So sine of u plus v, remember that's just sine cosine plus or minus cosine sine, right?
Mhm.
So that's going to give us sine x cosine 2x. That's going to work better. Minus,
Yeah, why wouldn't it be
plus, you're right, plus sine 2x cosine x, right? And cosine 2x, we're going to write this in the convenient way, right? The convenient way would not be cosine squared minus sine squared. It would be 1 minus 2 sine squared, right? So we'll write this one as sine x times 1 minus 2 sine squared x, right? And you see how we get that? Cosine squared minus sine squared, we'll turn the cosine squared into 1 minus sine squared, minus another sine squared, right? Gives us 2 sine squared minus 2 sine squared, okay? Plus sine 2x, well that's just 2 sine cosine. Times cosine makes that a square, right? So what do we get? If we distribute this through, we get sine x minus 2 sine cubed x plus 2 sine x, right? Cosine squared x. So what can I factor out? Sine x. Yeah. So if I pull a sine x out front, I'm left with 1 minus 2 sine squared x plus 2 cosine squared x, right?
Can you change the cosine squared x to?
I can't. I change the cosine squared x to a 1 minus sine squared x, right? So this is going to become, and you guys are really, you're getting a good dose here of what our strategies are. We want to make, not only do we want the arguments to all be the same, if we're going to factor this thing, because, I mean, we're doing this we're solving an equation, first of all, in sine x, in terms of sine x, and then we'll use a unit circle to see when those values occur for sine x, right? But this is a sine and that's a cosine. So I want to turn everything into the same species here of trig function, right? So we get 1 minus 2 sine squared x plus 2 times the quantity times the quantity 1 minus sine squared x, right? And so that's going to end up giving us sine x times, let's see, 1 plus 2 is 3, minus 2 sine squared x minus 2 sine squared x is minus 4 sine squared x, right? Everybody with me? Okay, and so this time we are going to get some interesting stuff. This time we're going to get the equations sine x equals 0, or what if I set this equal to 0 and solve? This is going to give me sine squared x equals 3/4, right? Everybody agree? So if I square root both sides, I'm getting sine x equals plus or minus square root of 3 over 2. That's a point that we know, isn't it? Okay, on the unit circle, where are these things happening? There's lots of places, aren't there? Right, we're going to get lots of potential inflection points here, right? So where's that happening? Sine is equal to 0, where?
At 0, 5, or 2, 5.
Okay, so in our domain, our domain is going from 0 to 2 pi. So the endpoints are gonna be, right, but those are endpoints anyway, so we'll check those anyway, right? So our places would then be, well, that's a lot of work for one problem, huh? So that's gonna give us 0, pi, and 2 pi. Pi is the internal one. What about where sine x equals, so the y coordinate is plus or minus square root of 3 over 2? Well, that's gonna be there, and there, and there, and there, right? So that's pi thirds, 2/3 pi, 4/3 pi, right? So really what we just got here, turns out, are all the multiples of pi thirds, aren't they? Pi thirds, 2/3 pi, 3/3 pi, 4/3 pi, 5/3 pi, 6/3 pi, 7/3 pi, etc. Lots of them, right? Okay, so when we make our table then, when we make our table, we have like 2. Well, why don't they give us more time?
Yeah, that's the issue. Can we just stay in during lunch? Is that okay?
No.
Sure.
No.
No.
Oh, you're a real bro, John.
Guys, we could just all pack one too.
Guess what? No.
I do honestly wish that this was a block
Jonathan
grenade.
for I'm
Yeah.
going to buy everybody's food?
Yeah, I think that is.
So what are the values gonna be then? We're gonna get 0,
2
pi thirds, 2/3 pi, pi, 4/3 pi, 5/3 pi, 2 pi, right?
Yeah.
So those are all the places. So in our table, we're just gonna have to, we're gonna have to have a lot of test points.
What about the negative sine x? Like the whole derivative, the whole second derivative?
Oh, did we, what do you mean, the whole, like what, second derivative one?
Yeah, because the first part was negative sine x, so find the 0 left.
Did we, oh, hang on, did we not finish this? Did we just, oh, you know what, we didn't.
We just did one part of it.
Yeah, we just did one part of it, you're right.
Yeah.
You're right, because look, we just did that part.
Guess we're finishing it
Right.
tomorrow.
Oh,
Finish it tomorrow.
no.
So what may happen is, this could be a blessing in disguise, because what's likely to happen when we go back and do this correctly is we're gonna end up probably not getting so many critical numbers, right? Which would be good. Ain't nothing but a thing, that's all there is to it.